Before we begin, I want you to imagine something impossible. Imagine Earth without oceans. No waves crashing against the shore, no rain tapping against the ground, no rivers carving valleys through land, no clouds drifting silently above your head, just endless rock, fire, dust, every living thing you've ever known, every tree, every animal, every human, depends on water. But here's the part almost no one talks about. Earth was not born with water. In fact, when our planet first formed, it was far too hot, far too violent, and far too unstable to hold even a single drop. So, where did all this water come from? Why does Earth have oceans, while most planets remain dry and lifeless? Tonight, we're opening Earth's deepest memory. Welcome to Earth's Archive. Welcome back to the channel where we uncover the hidden history of our planet, the stories buried beneath oceans, locked inside rocks, and written across the stars themselves. This is Earth's Archive, and today we're exploring one of the greatest mysteries in planetary science, a mystery that decides whether a world lives or dies. This is the story of how water came to Earth. Stay with me, because once you hear this story, you will never look at the oceans the same way again. Earth formed about 4.54 billion years ago from a massive cloud of gas and dust left behind by the birth of the Sun. This cloud slowly flattened into a spinning disk, and inside that disk, tiny particles began sticking together. Dust became pebbles. Pebbles became rocks. Rocks became worlds. But the early solar system was not calm. It was chaos. Close to the newborn sun, temperatures were extreme, so extreme that water could not exist as liquid or ice. Any water molecules that tried to form were instantly turned into vapor and blown away by powerful solar radiation. That means when Earth began forming, it formed dry. No oceans. No seas. No atmosphere like the one we know today. Just molten rock, endless impacts, and unimaginable heat. Earth wasn't blue. It was glowing red. Early Earth was a nightmare world. Volcanoes erupted constantly, pouring lava across the surface. Massive. Impacts shattered the crust again and again. The ground itself was unstable, floating on oceans of magma hundreds of kilometers deep. If you could somehow stand on early Earth, which you couldn't, you wouldn't see solid land, blue skies, or water. You would see fire. The surface of the planet glowed with heat. The sky was thick with ash and gas. The planet itself was still forming, still changing, still violent. This period is known as the Hadean Eon, named after Hades, the underworld. And during this time, water could not survive. Any water present would instantly boil into steam and escape into space. So, once again, the mystery deepens. If Earth began dry, if it remained molten for millions of years, how did it become a world covered in oceans? To answer that, we have to look beyond Earth itself. Far beyond. Out past Mars, into the colder, darker regions of the solar system, where sunlight was weak and temperatures dropped low enough for ice to survive. Out there, water could exist. And it did, frozen inside ancient asteroids, locked within primitive planetary bodies, trapped inside comets drifting through deep space. These objects were time capsules from the birth of the solar system, packed with frozen water and organic material, and during Earth's violent youth, many of them were sent inward, pulled by gravity, thrown off course by giant planets like Jupiter and Saturn. They began to fall. Around 4.1 to 3.8 billion years ago, the inner solar system entered a period of absolute destruction. Scientists call it the Late Heavy Bombardment. This was not a gentle drizzle of space debris. It was relentless. Millions of asteroids and comets slammed into Earth, carving craters, melting rock, and reshaping the planet's surface over and over again. Each impact released unimaginable energy. But they brought something else with them: water. The ice locked inside these space rocks instantly vaporized upon impact, forming massive clouds of steam around the planet. Impact after impact, steam after steam. Earth slowly became wrapped in a thick, suffocating blanket of water vapor. As time passed, Earth began to cool. The magma oceans slowly hardened, the surface stabilized, and gravity started doing its job. For the first time, Earth could hold on to an atmosphere. That atmosphere wasn't breathable. It wasn't blue, but it was dense. It contained water vapor, carbon dioxide, nitrogen, and sulfur gases, enough to trap heat and keep water from escaping back into space. And then, something extraordinary happened. The planet cooled just enough. Steam began to condense, and it started to rain. Not for hours, not for days, not even for years. It rained for thousands, possibly millions, of years without stopping. Endless rainfall poured onto the surface, filling every low point, every crater, every fracture in the crust. Water pooled, then spread, then connected. The first lakes formed, then seas, then vast global oceans. Earth was transforming before the universe itself, from a burning hellscape into a water world. For a long time, scientists believed comets were the primary source of Earth's water. After all, comets are basically giant snowballs flying through space. But science never stops at simple answers. When researchers analyzed the chemical fingerprint of water, specifically hydrogen isotopes, they discovered something unsettling. Much of the water found in comets did not match the water in Earth's oceans. The signatures were different, which raised a shocking question. What if comets weren't the main source of Earth's water? What if the real delivery system was something else entirely? That's when scientists turned their attention to a different type of space rock: carbon-rich asteroids. These ancient asteroids formed early in the solar system and contain hydrated minerals that hold water within their structure. When scientists analyzed these asteroids, the results were astonishing. Their water matched Earth's oceans almost perfectly. Unlike comets, these asteroids formed closer to Earth, making them far more likely to collide with our planet, which means Earth's water may not have come from distant icy visitors, but from nearby cosmic rubble. And yet, there's another layer to this story, one that suggests Earth didn't receive all its water from space at all. Deep within Earth's mantle, scientists have discovered minerals capable of trapping water, not as liquid, but locked inside their crystal structure. These minerals suggest that water was present during Earth's formation itself, buried deep, protected from heat, hidden for millions of years. As volcanoes erupted, that water slowly escaped, released into the atmosphere and surface over time. If that's true, then Earth didn't just receive water, it released it. And here's the most important part. Water arriving on Earth wasn't enough. Earth had to keep it, and that required something incredibly rare: the right gravity, strong enough to hold an atmosphere, a magnetic field, shielding the planet from the sun's destructive solar wind, a stable orbit, keeping temperatures within a survivable range, and the moon, stabilizing Earth's tilt and climate. Without these factors, Earth would have lost its water just like Mars, which means Earth wasn't just lucky. It was perfectly positioned, and this is only the beginning of the story. By the time Earth's surface finally cooled enough for liquid water to remain, the planet had crossed a line that very few worlds ever cross. It had become stable. Not peaceful, but stable enough for change to last. The oceans that formed were not calm blue waters like we see today. They were dark, acidic, and violent. Waves crashed against fresh volcanic land. Meteor impacts were still common. Lightning tore constantly through the thick atmosphere, but for the first time in Earth's history, something existed that could store heat, move energy, and reshape the planet itself. Water. Once liquid water covered the surface, Earth stopped being shaped only by fire. It began to be shaped by motion. Rain fell onto rock, and for the first time, erosion began. Water seeped into cracks, froze, expanded, and shattered stone. Rivers carved paths through the crust, carrying minerals from land into the oceans. Those oceans became chemical laboratories. They dissolved elements from Earth's crust: iron, sodium, calcium, magnesium, creating the salty seas we know. Today, every drop of seawater became a mixture of Earth itself. Water didn't just sit on the surface. It moved. Warm water rose, cold water sank. Currents formed, transferring heat from one side of the planet to the other. This movement stabilized temperatures, preventing Earth from becoming a frozen world or runaway furnace. Without water, Earth would have been extreme. With water, Earth became balanced, and balance is everything. As oceans deepened, the atmosphere changed too. Water vapor became clouds. Clouds reflected sunlight, cooling the surface. Rain regulated temperature. Evaporation and condensation created cycles that repeated endlessly. This was the beginning of Earth's climate system. Not perfect, not gentle, but alive, and deep beneath the waves, something extraordinary was preparing to happen. In the early oceans, the water was rich with dissolved minerals. Hydrothermal vents, cracks in the ocean floor where superheated water erupted from Earth's interior, pumped heat and chemicals into the sea. These vents created pockets of energy. Hot water met cold water. Minerals crystallized. Chemical gradients formed, and chemistry began to organize itself. Scientists believe these environments may be where life first emerged, not suddenly, not magically, but gradually. Simple molecules bonded together. Some structures were more stable than others. Some could replicate imperfectly. Some could store energy. Water made this possible. It acted as a solvent, allowing molecules to move, collide, and react. It absorbed heat, preventing delicate structures from breaking apart. It created environments where complexity could slowly grow. Without liquid water, none of this works. That's why when scientists search for life beyond Earth, the first question they ask is simple: is there water? As millions of years passed, life, still microscopic, began to alter the planet itself. Photosynthetic organisms appeared in the oceans, using sunlight to split water molecules and release oxygen as waste. At first, oxygen was toxic. It reacted violently with dissolved iron, rusting the oceans from within. Vast iron deposits formed on the seafloor, deposits we still mine today. But over time, oxygen accumulated. It escaped the oceans and entered the atmosphere. And Earth changed again. The sky slowly transformed. The atmosphere thickened. An ozone layer formed, shielding the surface from deadly ultraviolet radiation. All of this traced back to one thing: water. Water allowed photosynthesis. Photosynthesis reshaped the atmosphere. The atmosphere protected the surface. A chain reaction that turned Earth into a living planet. Meanwhile, the oceans continued shaping the land. Tectonic plates moved beneath the water, driven by heat trapped. Inside Earth, plates collided, forming underwater mountain ranges. Others pulled apart, creating deep ocean basins. Water filled every new space. As continents rose, Rain eroded them. Sediments washed into the sea. Coastlines formed and disappeared. The planet never stopped changing, but always, water was the sculptor. Even the moon played a role. The moon's gravity pulled on Earth's oceans, creating tides. These tides mixed nutrients, stirred coastal waters, and created shallow pools where early life may have experimented with complexity. Day after day, year after year, for billions of years. And through it all, Earth kept its water. That alone makes Earth extraordinary. Mars once had rivers, lakes, maybe even oceans. But Mars lost its magnetic field. Solar wind stripped away its atmosphere. Water evaporated or froze underground. Venus may have once had water too, but being too close to the sun, it entered a runaway greenhouse effect. Water vapor broke apart. Under intense radiation, and hydrogen escaped into space. Earth avoided both fates. Its magnetic field deflected solar wind. Its distance from the sun kept temperatures stable. Its gravity held on to the atmosphere, and its water remained, not locked, underground, not lost to space, but cycling endlessly between ocean, sky, and land. By the time complex life appeared, Earth had already been shaped by water for billions of years. Every valley, every canyon, every coastline. Water wrote Earth's history into stone, and it continues to do so today. The rain you hear, the rivers you see, the oceans you've never crossed, all of it traces back to cosmic chaos, ancient impacts, and a planet that somehow managed to hold on to its most precious gift. And here's the humbling truth. Earth's water is old. Older than the continents. Older than life itself. Some of it may be older than the sun. Every glass of water you drink contains molecules that have passed through comets, asteroids, magma, oceans, clouds, dinosaurs, and ancient seas. You are drinking the history of the universe, and yet, we still don't know everything. We don't know exactly how much water came from space. We don't know how much came from Earth's interior. We don't know why Earth kept so much while others lost nearly all of it. What we do know is this. Without water, Earth is just another rock. When we step back and look at Earth from space, it's easy to forget how unusual our planet really is. A blue sphere, wrapped in clouds, shining against the darkness. That blue color isn't land. It isn't vegetation. It's water. And as far as we know, no other planet in our solar system looks like this anymore. But here's the question that pushes the story beyond Earth itself. Is our planet special? Or are we simply one example among many? To answer that, scientists have turned their attention outward, searching for water beyond our world. They've found it in places we never expected. Water ice on the moon, hidden in permanently shadowed craters. Vast, frozen oceans beneath the surfaces of moons like Europa and Enceladus. Water vapor plumes shooting into space from cracks in icy crusts. Ancient riverbeds on Mars, carved by flowing liquid billions of years ago. Water is not rare. What's rare is liquid water lasting on the surface of a planet for billions of years. That's the real miracle. Many worlds receive water. Many worlds lose it. Earth kept it, and the reasons why are subtle, fragile, and terrifyingly precise. If Earth were slightly smaller, gravity would have been too weak to hold an atmosphere. If it were slightly closer to the sun, oceans would have boiled away. If it were slightly farther, water would have frozen solid. If the magnetic field failed, solar wind would have stripped everything bare. Even the moon matters. Without the moon, stabilizing Earth's tilt, climate would swing wildly, making long-term stability nearly impossible. Every one of these factors work together. Remove just one, and Earth becomes unrecognizable. This means something profound. Water alone does not make a living world. A planet must protect it. Hold it, cycle it, balance it. Earth succeeded where others failed, and because of that, water became more than a substance, became a system. Rain fell, rivers flowed, oceans breathed heat into the atmosphere and pulled it back again. Ice advanced and retreated. Sea levels rose and fell. Water regulated Earth's heartbeat. Even today, it still does. The oceans absorb vast amounts of heat from the sun, slowing climate change. Currents distribute warmth across continents. Clouds reflect sunlight back into space. Water keeps Earth alive, even as we push it toward instability. And here's something that should make you pause. The amount of water on Earth has barely changed in billions of years. The water you see today is ancient. It has been recycled endlessly. Ocean to cloud, cloud to rain, rain to river, river back to ocean, over and over again. The same molecules. Again and again. Some of the water inside your body may have once fallen as rain on a volcanic wasteland. Some may have flowed through ancient seas where the first life evolved. Some may have been locked in glaciers during ice ages. Some may have passed through creatures that no longer exist. Water remembers Earth's entire story, and yet, despite its importance, water remains fragile. Earth holds a vast amount, but only a tiny fraction is usable for life on land. Most of it is salt water. Most fresh water is locked in ice or deep underground. What we depend on is a thin layer. Rivers, lakes, shallow groundwater, a film spread across a planet. And that thin layer is all that separates abundance from collapse. When we understand where water came from, we also understand what's at stake. It didn't arrive easily. It wasn't guaranteed. It survived catastrophe after catastrophe, which makes the future question unavoidable. If Earth's water is so rare, if keeping it required such perfect conditions, then what does that mean for life elsewhere? Are there other blue worlds, quietly orbiting distant stars, their oceans waiting to be discovered? Or are we standing on one of the universe's few miracles? Astronomers are already finding planets in what's called the habitable zone, places where liquid water could exist. Some may have oceans deeper than anything on Earth, but we don't yet know if those worlds can hold on to their water. We don't yet know if they have magnetic fields, or stabilizing moons, or the delicate balance Earth maintains. For now, Earth remains our only confirmed water world that supports life, and that makes our oceans more than scenery. They are evidence. Evidence that chaos can lead to order, that destruction can deliver creation, that a dry, burning rock can become a living planet. All because water arrived and stayed. So the next time you hear rain, or stand beside the sea, or hold a glass of water in your hand, remember this. You thought you are touching something older than mountains, older than life, possibly older than the sun itself. You are holding the history of the universe, and Earth's story is still being written. If you enjoyed this journey through deep time, make sure to support the channel by liking the video and subscribing to Earth's Archive. We explore the hidden history of our planet, the forces that shaped it, and the cosmic events that made life possible. More stories are coming. More mysteries. More forgotten chapters of Earth's past. So stay tuned and stay with us for future videos because Earth still has secrets left to tell.